Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom, as I'm still in my sweaty, I ran 3 miles earlier today clothing. Step on inside, and this is the last video you're going to see in this get up here as I deal with arithmetic series. Next video coming up at some point will be geometric series. You'll have to wait on that one, but arithmetic series, geometric series, etc. We came off arithmetic sequence, geometric sequence, sequences being a list of numbers, a series being a sum of your terms in a sequence. So let's look at arithmetic series and what we're going to do with them. So this first question says the first four, write the related series for each finite sequence, then evaluate the series. So what they're saying is the related series for the sequence is, or when they say finite, it means that it terminates, it ends at some point right here. And to write the series for it, it's the sum of all these terms. So I'd say 20 plus 30 plus 40 plus 50 plus 60 plus 70. Not very hard to do, but that's just, making sure that you know how to do it, reinforce the idea and the pattern of what a series actually is. So as far as that goes, great, and then you evaluate it. So we add them up. Well, 20 plus 30 is 50, plus 40 is 90, plus 50 is 140, plus 60 is 200, plus 70 is 270, and you could be there and done with your answer, and that's very good. Now, all of these will be finite for an arithmetic series. We are going to learn about the infinite geometric series, but in an arithmetic series, see if this kept going on for in the forevers kind of spectrum, it just keeps getting larger toward positive infinity, or if it went backwards toward negative infinity. So we need these to be finite to see what would happen here. Geometric series is a little different. They can have convergence, and you'll see them when we talk about those videos. Now, that is one way to go about and do that answer, and I'm going to leave it for that one, and for these ones here, I will just straight up do addition for you. We'll go back and look at these ones when I start talking about what if we have more terms to an insurmountable kind of, I don't want to use a calculator for this kind of thing, or I have to find my values in a more difficult way. There's more that we can do formula-wise that we're going to get to. So let's just do these ones kind of really quickly and then move forward for those. Number 2, we're going to write this as negative 6 plus negative 3 plus 0 plus 3 plus 6 plus 9 plus 12. You could put minus 3. That's fine. Just understand that we are adding in between, and adding a negative becomes subtraction. Negative 6 minus 3 is negative 9. Plus 3 is negative 6. Plus 6 is 0. So we went back to 0. Plus 9 is 9, plus 12 is 21. So 21 there. Yeah, all we're doing is just series talk. And again, I'll go back to these when I want to talk about them here. All right, this one's maybe not as fun to do in this way. It all depends on, common denominator is not the worst thing on this one, but we'll get to it. Negative 3 halves. I definitely want to show you the talk on this one later. I'm not going to write the pluses in between. Adding a negative is subtraction. So minus this, minus that, etc. So like I said, common denominator, I got to take these ones that divide by 2. And then we're going to go ahead and, fix that up. Now, what's interesting about this one is it is an arithmetic sequence. That means it does have a common difference, right? That's what all these things do have. If you look back at this other one, common difference of 10, common difference of 3. So this has a common difference as well. I don't know what it is. But if I wanted to use a little shorthand version of how to solve this thing, I would be obtaining that common difference with you. So this becomes 9 over 6, or negative 9 over 6. And this becomes negative 39 over 6. So, oh boy, take out that calculator, huh? What I'd rather do is look at negative 10 minus 20 minus 30 and add 6 to that. You want me to do that? So negative 10 minus negative 30, negative 60, negative 100. I want to see if I get this right. Negative 2 tenths. I'm going to guess it's negative 204. Let's see. So negative 28 minus 29 is negative 57. Minus 39 is negative 96. Minus 49 is negative 145. Minus 59 is negative 204. I don't know if I said negative 204 before, but that's what I'm getting. So this becomes negative 204 over 6, right? Common denominator. This can divide by 6 evenly. Negative 34. Negative 34, I think. So I think that is the sum of all those numbers together. It's kind of nice that it panned out cleanly if it did. I might have to check an answer key for that. I am a solution guide video, but I'll go back to a problem like this maybe to talk about the formula stuff I'm going to be bringing up pretty soon. Number 4, we add these up. 2.1. Let's try that again. 2.1 plus 4.5 plus 6.9. 9.3. Now you probably have a calculator handy. I do too, but I'm not really looking to it if I don't have to use it. Because again, I kind of want to show you some things. All right, let's see. I should pretend like there's no decimal there, but that's okay. All right, so 6.6 plus... man, I'm going to use a calculator for this one. I don't want to mess it up. All right, so 2.1 plus 4.5 plus... I should really pause my video here. Race me. You ready? Let me know if I'm right. I can mistype on a phone calculator because I don't use these. 16.5. All right, I'm getting 65.1. So 65.1. So that's what a series is. You take your sequence, you add up the result, and you get a series. Now, you're saying, what makes these hard? Well, these were pretty straightforward because I'm just telling you to add them. Boom. And they were relatively small enough, right? The number, there are only 7 terms here at most that you ever saw. Relatively small enough. What if you have 15 terms? And you don't have sight, and you don't have sight of what all those other terms are, and you got to find them out each time, right? I don't have a list of what they are. You could write the list, but you're spending a lot of time to do that. By the way, we're not evaluating this series. We're using something called sigma notation. And on the back of this page, we're going to use what is already in sigma notation to evaluate a series, to which I'm going to show you some formula stuff. But sigma notation, write each arithmetic series for the specified number of terms. See, this is something where I'd want to get a little deeper into a formula and do things. And what if it's 100 terms? What if 1,000 terms? They can get huge. So here's what sigma notation is. Sigma notation is using the Greek letter sigma. It's the capital version, I believe, of sigma. And n equals 15 means there are 15 terms in this list. Like the 4th term would have been 28, the 5th term is 35. And I know this because, by the way, there's a common difference of 7. We got to get into that in a second. Because there are 15 terms, that means that we are going to evaluate a series adding up every term in the series from the first term of n to the 15th term. This is a part of what you're going to see even on this side as well. Take a look at that. N equals 1 to 14. So this is something as a part of sigma notation that we are going to provide and say from the first term to the 15th, this sigma means summation. It means take the sum of everything that you're going to do with n in this and increase n over time. We're going to put in some a sub n into here. Don't just write a sub n. What we're going to do is write the explicit formula for this. Because if I want to substitute n into an equation to figure out what the first term is, second term, etc., what better way to do it than, and by the way, we're not going to actually solve these, but what better way to do it than with the explicit formula? So what we have to do is come up with the explicit formula for this. So let's do that. To find the explicit formula, you need the first term, which is 7, and the common difference, which is 7. The explicit formula is a sub n equals 7 plus 7 times n minus 1. This kind of requires you know how to do arithmetic sequence stuff with me. Now, if you'd like to simplify this, because here's what I'm going to write. Inside here, I'm going to write 7 plus 7 times n minus 1. If you'd like to simplify it, you could distribute this 7 here. That's more 7s than I need. And 7 minus 7 is 0, so this would just be 7n. So there are 2 different answers you could write here. This one is actually even better simplified than it normally ends up because those terms canceled. But this becomes 7n right there. Notice I put parentheses around here because if I didn't, then who's to say that this plus 7n minus 1 isn't a part or is a part of the thing? Maybe that's the part I'm evaluating, you know? Just like that. But you need parentheses around this one, and this was only one term, so it's not really a requirement. So I answered this, okay? This is the final answer, or this is the final answer. So what did I say here? Just to kind of show you when I start doing for the next problems. And let's use this one as an example because it's a cleaner thing to look at. What this says is sigma is a function, is a symbol to function adding things together, to take the sum of different things. What we're going to do is take the sum of every term where we substitute a value for n, such as 1, and increase n by 1. 2, 3, 4, etc., all the way to 15. We're going to evaluate these from 1 to 15. Now, we're not actually going to do it in this problem. They only ask you to use the thing. But see if it does work out with our sequence. 7 times 1 was 7. 7 times 2 is 14. 7 times 3 is 21. And it would go on. That does seem to match what we had here. So this notation is responsible for providing that list for you. So why would we write this instead of this right here? Because maybe you don't have any of the numbers in the list yet, because this is technically shorter than writing this thing out. I know this took more work to do, but that's what that thing means, and that's where we can evaluate it there for sure. And pretty soon we're going to come up with, this wasn't really a formula, this is use of a function. Pretty soon we're going to come up with a formula for how we can do this in a relatively quick fashion without actually needing to not only add all these, but you have to compute them. That's what I was kind of mentioning before. I have to figure out all these numbers first before I add them up. There's a way we can do it without needing to compute all of the numbers. We'll get into it from 7 through 10. Let's first start with number 6, though. So number 6, use sigma notation to write the series for the specified number of terms. This is 1 plus 4 plus 7 all the way to 11. For us to do this right, we need the explicit rule for this thing. So let's start with that this time. The value of the first term is 1, and the value of the third term. The value of the first term is 1, and the common difference is 3. So our notation here says we are going to go from the first term to the 11th term. I'm used to writing n equals. If you ever see me do that, I apologize. I'm trying to break that habit because I know that symbol won't come up. From the first term to the 11th. Oh, I'm sorry. I still need the rule. Well, you know what? I'll write the rule right here. The first term to the 11th of 1 plus 3 times n minus 1. I feel a little dirty not writing the explicit rule first in full, because you know what I want to do is give you the simplified version as well, which is if I distribute 3 into here, then I'm going to get 1 plus 3n minus 3, and 1 minus 3 is negative 2. So this would be negative 2 plus 3n. You could also write 3n minus 2. This is more in that a sub 0 format, so 3n minus 2. I kind of like this more. So either of these are completely adequate and valid answers. And I would do that for you kind of each time if I see it occur. So those are the two different versions that you could write for that series thing. So that sigma thing, we're going to have to get used to it because we're about to run into problems that have it. And we're actually going to start evaluating some sums in a shorthand notation. I'm going to give you a formula in a second. For each sum, find the number of terms, the first term and the last term. Then evaluate the series. Now, they're not just blowing smoke for you. Finding n a sub 1. And by the way, it's not always technically the first. It's not always a sub 1. It's the first term of the series that they want. It might be a sub 2. It might be a sub 5. So when I say a sub 1, I really just mean the initial value that they give us. The last term is a sub n, and when I say n, I am referring to however large that we're kind of talking about there. So this is really hard for me to say in these ways, but I use these in my formula. So yeah, we're going to have to work off of it. All right, so for number 7 here, just to give you once again the idea of what we could do in a very primitive, practical way is when you're doing this summation, this is in essence an explicit rule because there's an n involved. We would first substitute 1 for n, like this. And then we would add substituting 2 for n. And then we would add substituting 3 for n. And we would keep doing that all the way to substituting 14 for n. Obviously, it's kind of easier to get these numbers a different way. 6 plus 0 plus 6 plus 3 plus 6 plus 6. You know, we would keep going there, whatever the numbers are. So we would do that. I'm not going to. What I am going to do, though, is get that first term. Oh, sorry, we still need to get n. From 1 to 14, that's 14 numbers. There are 14 numbers in between. So n is 14. My a sub 1, or my first value in my series, my first value here is, I'm going to plug it into there. So 6 plus 3 times that 1 minus 1 there. I'm sorry, we know what it is. This is, given that formula, it should be a sub 1 is 6. 6 plus 0 is 6 right there. The a sub 14, the last term for this thing, is 6 plus 3 times 14 minus 1, or 13. 39 plus 6 is 45. So that is your n, your a sub 1 and a sub 14. Now, here's what we're going to do. You might recognize, by the way, if I started to write out some of this list, you might recognize that in this series, common difference was 3. So this would be 6 plus 9 plus 12 plus 15, etc. And we would keep going several more times until we got to plus 45. Oh, I'm sorry. Let me do a few more terms before that. Plus 39. Give me a sec. Plus 39, plus 42, plus 45. Here's what we're going to do. In an arithmetic series, because of the nature of the common difference, there's this cool little feature to matching bookended terms and their sums. If I add 6 and 45 together, I get 51. If I add 9 and 42 together, I get 51. If I add 12 and 39 together, I get 51. You're going to get 51 as you keep getting closer and closer to the middle, and you will keep getting 51 as long as it's an even number of terms. Odd number of terms, there's going to be one middle value. We'll get to it when we run into one like a number 8. If I pair all these numbers off, I get 51 for each of them, and if I multiply 51 by the number of pairs that there are, then I'll get my answer. And that's exactly what we're going to do here. 51 times 7. There are 7 pairs. If there are 14 terms, then there are 7 pairs. I can divide 14 by 2 to figure that out, right? So my final answer, by the way, would be 7 times 51, which is going to be 357. I'm going to tell you that right off the bat right now. Now, the formula that I'm using to make this work is I'm going to use S sub n to represent the series of n number of terms here. And what we're going to do is take our number of terms and divide it by 2. This references the pairing off of our numbers that we're going to do. And you want to add your first term in your series with your, or in the sequence, with the last term in it right there. And this would be our formula. And the reason I say first and last is the same reason that they stated it here, because it's quite prevalent. You'll know how to get to them pretty quickly. Normally this shows up in your formula sometimes, or you can just plug it in pretty easily. And you can plug this in pretty easily because you know what it ends to. So if you find those two terms, they add to the same amount that any of the other ones do. So it's as simple as using those ones because they are the easiest to access compared to that of any other sets that'll get you 51. So what is the actual formula I should be doing here? It's S sub 14 equals 14 divided by 2 times 6 plus 45. And that gives me my 7 times 51, which is 357. So this sigma notation asks me to find the sum of this list, right? Essentially, that was the list. The sum of this list right here. And we're doing a shorthand notation of doing that using this formula above. And I'll continue to use it. So let's do it for the next problem here, number 8. So on number 8 here, the summation from n equals 1 to 11 of 4n minus 9. Now this isn't the exact explicit formula as it is with the first term here, so don't assume that 4 or negative 9 is the first term. If you want to get the first term, you're going to have to substitute 1 into here. So let's start by addressing how many terms there are. 11, from 1 to 11 there. Now your a sub 1, let's actually substitute 1 into here. 4 times 1 minus 9, that's negative 5. A sub 11 will be the last term in the list. That is 4 times 11 minus 9, which is 35. So what we're going to do is use that formula there to find the series, to evaluate the series for the first 11 terms. You're going to divide 11 by 2 and multiply that by negative 5 plus 35. 11 over 2, well, I'll just leave it like that for now. So 11 over 2 times 30, negative 5 plus 35. And 30 over 2 can reduce to 15 over 1. And 11 times 15 is 165. And that's the answer here. Now, an interesting bit, as we did have, a fraction. We had a decimal. This would have been 5.5. Mr. Robinson, there are 5.5 pairs. How does that work out? Well, if you had this list written out appropriately, negative 5 would have been the first number, and then negative 1. The common difference is 4. And then negative 1, and then 3. Oh, sorry, I would add these, huh? Negative 5 plus negative 1 plus 3 plus etc. all the way to kind of your last numbers in your list here. Well, should I write them out? I'd have to write the whole thing out. The bottom line is this. There's an odd number of terms. So I'd pair these things off, pair them off, pair them off, pair them off, and eventually there would be a number in the middle. The middle number doesn't pair up with anything. Okay, the middle number doesn't pair up with anything, but and since it doesn't pair up with anything, it doesn't add with anything. So unlike the other ones that are adding together to make a larger number, this one is staying as is. That middle number is exactly half. of the sums of any of your other numbers, right? When you add all those ones up. Let's take a really quick example. 1 plus 2 plus 3 plus 4 plus 5. If I add 1 and 5 together, I get 6. 2 and 4 together, I get 6. This 3 is just a 3. See, 3 is half of these 6s. So we have two pairs. We have two pairs here, and then half of, not half, well, it's half of a pair, but half of the sum of what those pairs are too. So when you do 5 over 2, that's 2.5, and we multiply 2.5 by your, first and last term, by that 6. What you're doing is you're getting those two 6s added together, plus half of a 6. Plus half of a 6. So the formula still takes care of it even with an odd number of terms. That's not going to change in those problems there. Anyway, we get 165 for there. Okay, number 9. We're going to go from 2 to 8 for this thing here. So same things apply here. We got to find out the number of terms, and then we got to find out first and last term and then go here. But this one's a little different because we go from 2 to 8. So we're not going to ever do, the first term isn't a sub 1, it's a sub 2. Right? We're going to find a sub 2 and a sub 8. The other tricky part about this is if I ask how many terms there are, I say, how many terms are there from 2 to 8? And a lot of people will say 6. Well, let's back up a bit. What if I asked how many terms are from 1 to 8? Generally, people will say 8, and they're right. It's 1 to 8. So why is from 1 to 8, 8, and 2 to 8, 6? Wouldn't it be 7? 2, 3, 4, 5, 6, 7, 8. That's 7 terms. What's the problem with doing 8 minus 2? Because when I say what is 8 minus 2, count from 2 to 8 that way, you don't count 2. We say 3, 4, 5, 6, 7, 8. You got to count the 2. 2 is one of the terms here. I do want to do 8 minus 2. Plus 1. You got to count the term you start from. When I say what's the difference from what, if I say how many terms are from 1 to 8, you're doing 8 minus 1 plus 1. That's what gets you the 8 that we're looking for here. This is 7. 8 minus 2 is 6, plus 1 is 7. There are 7 terms from 2 to 8. 2 counts as one of them. That's the other tricky part, right? So you got to be very careful about that. Make sure that you're including that one in. Because it's very easy to just subtract and leave it alone. Okay, the second term in this thing is 5 plus, hey, let's try it this way for the second term. The second term, notice this is an explicit rule for an arithmetic sequence. The first term is 5, common difference is 4, 5 plus 4 is 9. Okay. The eighth term, let's do that actually. 5 plus 4 times 8 minus 1, or 4 times 7. 4 times 7 is 28, plus 5 is 33. So here we go. We got n, a sub 2, and a sub 8. And again, a sub 2 is the first term in this case. Now we are going to find S7, because there are 7 terms in this thing. So that is 7 over 2 times a sub 2 plus a sub 8, which is 7 over 2 times 42. Half of 42 is 21. 21 times 7, 147. So that is the sum of that there. The last one, number 10, before we get these last two. And before I do the last two here, I probably want to go backwards and talk about how you could do it for those first problems, specifically that fraction one. All right, on number 10 here, we got to find the number of terms n. 13 minus 5 is 8, plus 1 is 9. From 5 to 13, there are 9 terms counting 5. Don't forget to count 5. Now I need the first term, which is a sub 5, not a sub 1, and that is 5. This is not that other form, so it's best to probably plug it in. 5 minus 6 times 5, 5 minus 30 is negative 25. And then a sub 13 is 5 minus 6 times 13. Remember, there's no minus 1 here. I almost messed myself up there. 6 times 12 is 72, so 78, so negative 73. All right, negative numbers here. That's okay. All right, so S sub 9 is 9. Sorry, a lot of odd numbers here. It's 9 over 2 times negative 25 plus negative 73, or negative 25 minus 73, and that is 9 over 2 times negative 98. I don't want any of these to be wrong. Sorry if they are. Negative 98 over 2 is negative 49. What's nice about these is we divide these by 2, and unless your values weren't integers to begin with, your answers will be integers. They'll be able to divide by 2. That'll be fine. 49 times 9, negative 49. 50 times 9 is 450 minus 441. So negative 441 is the sum of those. And you can check these in a conventional way. If you're not certain, you can. But you do have to figure out what all the terms are. So we are going faster with this, even with just a small amount of 9 terms or 7 terms. We're likely going faster here than we would by plugging them all in, adding them all up, using the calculator, all that kind of stuff. All right, before I do 11 and 12, I just wanted to point back at, like, we could have done it for these problems here. And again, 7 terms. This was a little faster because we already had the terms here. But in that summation notation, if there were dots right here and you had to find them, it's going to take a little while longer. But for a problem like this, this might take a moment because I still have to find the common difference, right? I'd have to figure out what... Well, actually, no, I wouldn't. I wouldn't have to find the common difference because I already have all the terms. So here's my first term. Here's my last term, and I have 1, 2, 3, 4, 5, 6 terms. So let's see. Let's just try it with this one. Let's see if it works out and gives us the same negative 34, because I don't know if this was right. So S sub 6 is 6 over 2. We pair them off times, and honestly, I would have rather paired off, I would have rather paired off these because I get a common denominator. I have it, though. Times negative 9/6 common denominator minus 59 6. That's no fun. 6 over 2 is 3, right? So 3 times negative 68 sixths. So 3/6 reduces to 1/2. And negative 68 over 2 is negative 34. So we do get that. Obviously, it still works out, but now I trust that I got that answer correct. Okay, let's do the last 2 problems here. And I was really nice about these last 2 problems. There are ways that I could have made this very, very hard. Giving you enough information, we can find this pretty fast. Determine the number of terms n in each arithmetic series. Your first term is 45. Your last term is 135. And when you add up the things in the series, you get 900. Now, what's interesting is they don't provide you a common difference, right, to find out what you're adding to get up to 900. So this makes it, I don't know, maybe impossible to do without that formula or the idea of what's happening here. What you have to know is that these 2 numbers combine to be what the next 2 numbers inside do, etc. We do have enough information to find n based on that formula. We're going to use this formula here, and the only variable we don't have is n. So this is one of those cases where you really do need the formula for this one, kind of, in a way, right? Because we don't know what the numbers are in between unless you guess how many terms there are to then say, now here's the common difference. But I'd rather not do all that. So let's substitute. 900 goes in for S of n. We don't know n, figuring that out. A sub 1 is 45. A sub n, that nth term, whatever it is 135. If you don't mind, I'm going to multiply both sides by 2. It's probably something you should kind of do each time. I'll do it early on. So that's gone. So now I have 1800 here. So 1800 equals n times 180. So 180n, divide both sides by 180, we get n equals 10. There are 10 terms in this list. It would be even better to say now find the common difference. Would you know how to find the common difference? Well, you would go to, I'll do it for this problem. To find the common difference, you'd say, use your explicit rule. A sub 1 plus d times n minus 1. Where now, the only thing we don't know is d. We'd say, well, a sub n is 135. A sub 1 is 45. And n is 10. You can solve for the common difference this way. There are kind of other ways to logically do it, but it goes back to this algebra right here. 10 minus 1 is 9, right? Subtract 45, you get 90. 90 equals 9d. Divide both sides by 9. D is also 10. So common difference of 10. Apparently this list is 45 plus 55 plus 65 all the way to 135. 10 terms doing that. And that's what gets you 900. Little lesson in there. All right, number 12, last one. Same exact dish as before. Substitute things into there, solve for n. Not going to make it any more difficult than that. 4,540 equals n over 2 times. And again, these can get really difficult regarding they can go into solving quadratic territory, and those quadratics aren't necessarily fun because these numbers get so big. 4, 5, 4. This time I'm not going to multiply by 2 until the end. N over 2. You know what? Yes, I am. I don't want to deal with that algebra. That's dumb. Multiply both sides by 2. And we'll get 9,080, I think, equals 227. And I don't know that number. It looks like it'll probably hopefully be clean here. 9,080 divided by 227. I get 40. So we get n equals 40. There are 40 terms in between. I'm not going to find the common difference for you, but you see how you can do that there. And that's it. That's the end, guys. All right, so that ought to do it for this one. They got it in about a half hour's time. This is Mr. Robinson. Thank you so much for watching, guys. I will see you in the next one when I do geometric series. Take care.